All right, guys, let's do this. 4004, probably one of the most important code rules. This is for determining the maximum ampacity of wires and cables. So there's a number of different things we're going to look at in 4004. So just summarizing them, we're going to look at whether we're using copper or aluminum conductors. Right? Those guys are going to have different tables and different ampacities based on the physical characteristics of copper and aluminum. Then we're going to look at the insulation type and the temperature rating. Right? Is it T90? Is it RW90? Is it TW75? Number 3 is not actually part of 4004. I just wanted to put it in there to keep in mind that once you actually terminate these conductors, then the temperature rating of the entire install is based off the maximum temperature rating of that termination point. So at the moment, for this video, we are just looking at the conductors, and we're just saying like how much current can we max out on these conductors, not keeping in coming into play would be the termination of those guys. That's going to be a separate rule. And once we terminate the conductors, then we're going to have to change our temperature rating. At the moment, we're just going to go off of 90 degrees, 75 degrees, if we have T90, RW90. But just keep in mind, most terminations are usually 75 or 60. There's very few temperature ratings of terminations that are actually in the 90 degrees. So we'll most likely have to reduce our rating of our conductors down to 75. Okay, so we're just looking at the conductors in the pipe, not terminating it, just maximum ampacity. I find it's a little bit confusing to start like this, but it is like the first fundamental step of looking at the max ampacity, and then we'll look at other rules as to why the ampacity gets reduced, because the termination temperature rating is usually about 75 degrees. Okay, so once we've looked at copper or aluminum, then we've looked at insulation type and temperature rating. Then we're going to look at whether it's installed in a conduit or in part of a cable assembly, or whether it's a free air install. That's going to determine which of the tables 1 through 4 that we're going to look at to find our base maximum ampacity. Once we've done that, then we got to look at the ambient temperature. Is it above 30 degrees? If so, we're going to have to use table 5A, A for ambient temperature. And then if we have more than 3 conductors in the cable or the conduit, we're going to have to use 5C to derate our ampacity as well. Okay, C for conduit or cable. Obviously, everybody knows the reasons why we're trying to determine the max ampacity. We want to make sure that the insulation of the conductors is not degraded, and we want to make sure that the copper has the ability to carry that current that we're having to draw with each of our loads there, right? Last thing we want is for the insulation to break down and have a line-to-line short or a line-to-ground short. Doing this where we jam in a disgusting amount of conductors into the pipe and don't allow for free air to dissipate that heat, not good practice whatsoever. And obviously we're gonna be costing ourselves money later on, right? Because we're gonna have to be troubleshooting and coming back on the installs that have gone crispy because the conductors are pulling too much current and we didn't size the conductors properly. The other thing I have to keep in mind is also once you terminate these conductors, if you've exceeded the ampacity of the conductor, that conductor is going to be hot. It's going to start to degrade the insulation. It's also going to start to create hot temperatures on the termination point, degrade the termination point, degrade the plastic of the breaker or whatever other terminal that we've connected up to, and create hot spots and resistance, which will further cause issues on more heat and down the line a fault there. So lots of reasons why we want to keep track of the ampacities of our conductors. I do have a flow chart here on where we're going, on whether we're doing table 1, 2, 3, or 4, and then when to look at 5A and 5C. But let's take a look at the code first. So let me just step out here, look here. So we're on 4004, okay? And we're going to look at just a couple of rules so far. So we're not looking at, buried raceways or anything like that. We're just looking to look at just the basics. And we're not in this video, if you're looking for like different numbers of, 4 number 6s and 10 number 10s in the same pipe. This video is not going to cover that. This is just going to cover free air installs and the same gauge of wire in a pipe. And then we'll talk about ambient temperatures being above 30 degrees. So the other, getting a little bit more complicated, will be covered in subsequent videos. Okay, so let's take a look at 4004, ampacity of wires and cables. Keep in mind there are rules in Appendix B. These rules we're going to look at are just going to be for free air installs and for placing the conductors into a raceway or a cable. We're not going to be looking at direct burials or anything like that. That's going to be covered in subsequent videos. We're also not going to look at like different gauges of wire in the same pipe, right? You know, like 3 number 6s and 6 number 10s in the same pipe. This video is not going to cover that. Subsequent videos will cover that. This is just going to cover one gauge of wire, and then above like 3 conductors, above 3 conductors, and then we'll look at ambient temperature and how that affects and derates those conductors as well. Okay, so let's take a look at the first one. We got 4004 subrule 1. That one is for copper conductors, and if we're doing single conductor installs in free air, we're going to be looking at table 1. Okay, if we're looking at up to 3 conductors in a raceway or up to 3 conductors in a cable, we're going to be looking at table 2. So tables 1 and tables 2 are for copper. Free air is table 1, and raceway or cable up to 3 conductors is table 2. Okay, we'll see later on that once we get up into 4 conductors, then we're reducing the amount of free air that's in the pipe to allow those conductors to dissipate their heat. So we're going to have to go to table 5C to derate the ampacity. Okay, so copper is tables 1 and tables 2. Taking a look at aluminum conductors, those guys are going to be table 3 and table 4. Table 3, again, is going to be single conductors in free air. Table 4 is going to be up to 3 conductors in a raceway or a cable. And then again, if we're going to go above 4 conductors, then we're again going to be making use of table 5C. Okay, so quickly, copper is going to be 1 and 2, aluminum is going to be 3 and 4, and if we're above 3 conductors, we're going to be using table 5C. Okay, the other rule that we're going to be making use of is this guy right here. The ambient correction factors of table 5A, where conductors are installed in an ambient temperature exceeding or anticipated to exceed 30 degrees. So once we go above 30 degrees, then again, it's too hot, the conductors can't dissipate their heat, and so we're going to have to derate based on that ambient temperature there. Okay, one of the questions that will come up probably in the comment section is whether the neutral current is going to be used for determining ampacity. So the rule for that is subrule 3. Sorry, my highlighter crapped out of me. So subrule 3, neutral conductor that carries only the unbalanced current from other conductors, as in the case of normally balanced circuits of 3 or more conductors, shall not be counted in determining ampacities as provided in subrules 1 and 2. So if you have a 120, 240 install, the neutral is going to carry the unbalanced loads, right? It's not carrying the full current that the current carrying conductors are. Okay, if you're looking at 3-phase 120/2/8 installation or a 347/600 install, the neutral in that Y is only carrying the unbalanced load. So in that case, in both cases, the neutral conductor is not being used in order to determine the ampacity. So neutral conductor may be in the pipe, but we're not using it in order to determine ampacities. Okay, so let's move on to a couple different examples. Let's go back to the PowerPoint here, and I'll show you this kind of flow chart that I've created here. So first thing we're going to look at is the insulation temperature known? We're going to do another video on table 19, but if we don't know the insulation temperature, then we're going to have to go to table 19. All of the examples that we're going to be given in this video are going to tell you the insulation temperature. Okay, so yes, we know this, our insulation temperature. Then next question, is it copper or aluminum? Copper is going to be 4004 subrule 1. Aluminum is going to be subrule 2. And then our next question is this a free air install, or is this in a conduit or a cable? Right, so free air copper is going to be table 1, and then in a conduit or cable is going to be table 2. Okay, for aluminum, free air aluminum is going to be table 3, and then in a conduit or a cable we're going to be looking at table 4. At that point, once you've looked at tables 1 through 4, you found your maximum ampacity. If you have less than 4 conductors in the conduit or the cable, or if it's 30 degrees and below. Okay. If our ambient temperature is above 30 degrees, we're going to have to look at table 5A. And if we have more than 4 conductors, we're going to be looking at table 5C. Okay, and then eventually we're going to find the maximum ampacity. Okay, so let's take a look at a number of examples here, guys. Let me do a split screen so we can have this guy on the side and then the code as well. Okay, perfect. So first question is, find the ampacity for 2 aluminum size 4-aught RW90 insulation, 600 volt rating, run in PVC conduit with an ambient temperature of 30 degrees. And then I've put this note here for all of these examples. We're not taking into account the termination of the conductors. Okay, so we're saying conductors assumed to not terminate within 1.2 meters of any equipment. So it's like we're running these guys to a JB, and then from the JB, then we're going to go to the equipment. That's obviously not the case in most installations, but this is just to determine the maximum ampacity of each of these conductors. Okay, so I've got the answers on the next slide here. So first thing is we're going to look at whether it's copper or aluminum. Okay, so we're looking at aluminum, and then we're going to look at whether it's free air or a raceway or a cable. In this case, we have the conductors being run in PVC conduit. So at that point, we're going to be looking at table 4, right? So aluminum conductors in a raceway. Okay, so for here, we've got a PVC conduit, right? We're going to table 4, and we're going to look at 4-aught. We have 2 aluminum conductors, so we're below 3, so below 4, so we don't have to worry about 5C, and ambient temperature is below 30 degrees, so we don't have to worry about 5A. So at this point, once we look at table 4, that's going to determine our maximum ampacity. So 4-aught at 90 degrees, right? Why is it 90 degrees? Because it's RW90 installation. So we're in this column right here. We're looking down to 4-aught, and at that point, it looks like our maximum ampacity is going to be 205 amps max. Okay, this doesn't take into account the 80% rule or anything like that. This is just the maximum amount of current that you can push through this conductor and have it stay at 90 degrees and not degrade the insulation. Okay, so hopefully you're good with that example. Hopefully I'm not going too fast. What I failed to mention is that you can pause the video at each point, right? So pause the video here and then see if you can work through the answer, and then restart the video, and then I'll go through the answer for these guys. So the next one is single conductor armored power cables, copper, size 250 kc mil, XLPE insulation with 90 degrees rating, 600 volt rating, run on unistrut assembly in free air. Conductors are spaced properly. We'll talk about spacing of single conductor cables. If they're too close, we'll have to derate them as well, but they're a diameter apart, and so there's lots of free air for them to dissipate their heat. So we don't have to worry about ambient temperature because we're below 30 degrees. We don't have to worry about being greater than 4 conductors because we've got 3 conductors and they're all being run on free air. So we're looking at copper. We're doing a free air installation. So in that case, we're going to go to table 1. And what size we're looking at? 250 kc mils, right? So sometimes in the field you'll hear 250 kc mil. You'll also hear 250 MCM. MCM and KC mil are essentially the same thing. So we're at 90 degrees. So we're in the 90-degree column, down to 250 KC mils, and it looks like our maximum ampacity is going to be 455 amps being pushed through those 250 KC mil conductors. Okay, hopefully you're with me. Let's look at example number 3. Okay, again, stop the video, try and do it on your own, and then turn the video back on, and we'll go through the answers here. Okay, so next one is find the ampacity for a 3-conductor Tech 90 XLPE cable, copper conductors, size is 500 KC mils, 600 volt rating. So I'm putting the 600 volt rating because they have a voltage rating here within tables 1 through 4, right? Ampacities for single copper conductors, bare, covered, or insulated, rated at not more than 5,000 volts and unshielded in free air. If we look at table 2, it has the same voltage rating. So I'm just mentioning the voltage rating being 600 volts, obviously so that we can make use of tables 1 through 4. Okay, so what do we got? We got copper conductors, and we're in a cable, right? So at that point, we're going to be looking at table 2, right? So copper, we got a Tech cable, we're in table 2, size is 500 MCM, and the insulation temperature rating is 90 because we're looking at Tech 90 XLPE cable. So we're in the 90-degree column, we're going down to 500 MCM, and it looks like those guys are good for 430 amps each. Okay, so the steps here are not too complicated, right? We're looking at whether it's copper, free air, raceway, or cable, finding the right table 1 through 4, and just scrolling down on the appropriate column here. Okay, let's take a look at example number 4. I got 12 examples here, guys. Find the ampacity for 3 copper conductors. So 3, we don't have to worry about table 5C. Again, still doing the basics here, so we're below 30 degrees, so we don't have to worry about table 5A. We are copper conductors. There's 3 of them. They're number 6s. TW75 insulation now, 600 volt rating for all of these examples. This one's run in conduit with an ambient temperature of 30 degrees. Okay, so that means that if we are copper and we're conduit, then we're going to go to table 2, and we're going to look at number 6, right? So number 6, and keep in mind this is TW75, right? So the maximum temperature reading of the insulation is 75. So we're scrolling down here until we get to number 6, and that guy's good for 65 amps max. Okay, so hopefully you're getting the gist of this. Let's look at example number 5. Okay, next example. Find the ampacity for each of 3 copper conductors. Number 10, T90 insulation, 600 volt rating, run in flexible metal conduit with an ambient temperature of 30 degrees Celsius. Okay, so again, we're not worrying about terminations. We're not worrying about ambient temperatures, and we're not worrying about greater than 4 and above conductors. So we're looking at copper, and this is in a conduit again. So again, we're in table 2. So most of the time, the answers will be in table 2. So we're looking at number 10, and number 10 in the, what are we, insulation? Insulation is 90 degrees. So we're looking at 90 degrees here. Number 10s are good for 40 amps max. Okay, again, doesn't take into account the 80% rule or anything like that. This is the maximum amount of current that you can push through these conductors. Okay, let's take a look at the next one, guys. Hopefully you'll have to tell me in the comments whether I'm speaking too fast. I find a lot of my videos are drawn on and they're quite long. So let me know whether the pace is good or not. All right, next one, guys. Now we're looking at more than 3 conductors in a raceway. So we're gonna have to make use of table 5C. But first we've got to use tables 1 through 4, get our base ampacity, and then derate from there. So what do we got? We got 6 copper conductors, 2-aught RW90 insulation, 600 volt rating, run an EMT conduit with an ambient temperature of 30 degrees. So not worrying about temperature yet, but we do have to keep in mind that now we're above 3 conductors, right? We got 6 copper conductors, being 2-aught, run an EMT. So we're going to be in table 2, right? As usual, we got 2-aught. We're in the 90 degree column here. So we got 90 degrees. Let's go down to 2 aught. That's good for 195 amps. Okay, so that's our base max ampacity. That would be if we had, up to 3 conductors. Right? It says ampacities for no more than 3 insulated copper conductors. So we've got 195 amps that we can push through this conductor, being 2 aught. But the issue is that we have 6 of them. So for 6 of them, we got to go to table 5C. Okay, so we're writing down the fact that we have 195 amps that we could normally push through there, but because we have too many conductors in there, those conductors cannot dissipate their heat properly. So we're going to 5C, and we got 6, right? So we're going to be doing 4 to 6 conductors, and the correction factor is going to be 0.8, right? So we take our 195 amps that we got from table 2, multiplying by 0.8, and that should give us 156 amps max. Okay, so keep in mind that we did all the previous 5 examples using tables 1 through 4. Now we've got 6 conductors, so now we're starting to make use of table 5C. Okay, a lot of the times you're going to have more than 3 conductors in the conduit, so we're most likely going to be making use of table 5C going forwards. Okay, let's take a look at the next one, guys. Example number 7. Ampacity of 24 copper conductors. Number 10s, T90 insulation, 600 volt rating, run an EMT conduit with ambient temperature of 30 degrees. Okay, so don't worry about the temperature yet. Don't worry about terminating. Don't worry about the 80% rule. This is simply the maximum current that we can push through these conductors. Let's erase this. We're going to be coming back to table 5C because we've got 24 of those guys. But let's go to table 2. So answers are here. Let's walk through this. So we got copper. We're in a raceway being EMT conduit, so we're on table 2. And we got number 10s, and the insulation rating is T90, right? So we're in the 90 degree column. Let's erase the previous answer there. And we're going to look at what, number 10s. So number 10s are good for 40 amps, right? So we got 40 amps max, but we got a disgusting amount of conductors in the conduit. We're running 24 conductors together. So we're going to go to table 5C. So keep in mind the 40, right? Let's go to 5C. And we had 24. So now we're in 7 to 24. Easy now. 7 to 24 conductors in the pipe. And so our derating is going to be 0.7. So we're going to take the 40 amps that we had before from table 2, multiply by 0.7, and that gives us 28 amps max that we can run on each of these number 10s. Okay, so nothing too crazy. We're going to build up with other rules and everything, but hopefully you're getting the understanding of these base rules for 4004. Okay, let's take a look at ampacity for 6 copper conductors. Size is number 6, T90 insulation, 600 volt rating for all the examples. This one's run an EMT conduit as well, and we're not having to worry about ambient temperature yet. We're still at 30 degrees here. Okay, so we are still in table 2, so let's go back to table 2 here. Let's erase our previous answers here. What are we at? 90 degrees insulation again. The size is number 6, so we're going across to number 6, and that looks like it's good for 75 amps max. Okay, but we've got 6 conductors that are being run in that conduit, so we got to go to table 5C. So keep in mind 75. Going to table 5C, there are 6, so we're doing 4 to 6 conductors, and again we're at 0.8. So we're going to take the 75 amps that we found on table 2, multiply it by 80%, and we have 60 amps max that we can push on those number 6s because we have 6 of them in the conduit there. Okay, moving on. Got 3 more examples here, guys. Okay, so still with too many conductors, not too many, but more than 3 conductors in the conduit. What size are we at? Number 12, TW75. So watch the insulation rating there, 600 volt rating for each example. This one's run an EMT, and our ambient temperature at this point is still 30 degrees or below. Okay, so we are in table 2. So let's go back to table 2. Okay, let's get rid of this. We're not in the 90 degree column. We were in the 75 degree column here because we have TW75. Size is number 12, so it looks like those guys are good for 25 amps max. But we have more than 3, right? We've got 16 conductors being drawn through that conduit. So remember that 25. Let's go to table 5C. Okay, we got 16 of those guys. So we're in the 7 to 24 here. We're going to have 70%, so we've lost 30% of the ampacity there. So we're going to take the 25 amps that we had from table 2, multiply it by 0.7, and that gives us 17.5 amps maximum. Okay, next one, guys, number 10. All right, so we got ampacity for each of 9 copper conductors. Number 12's T90 insulation, 600 volt rating. This one's run in rigid conduit. So again, we're in table 2. So really mixing it up here. I've gone from table 2 to table 2 to table 2. So what do we got? We got copper conductors. We're a rigid conduit, so in a raceway. We're at table 2. We're in the 90 degree column here. So let's go to there. Table 2. Let's get rid of this. Okay, 90 degree column. What size? We're looking at number 12s. Number 12s are good for 30 amps. But we have how many? We got 9 conductors in the conduit. So we're going to go to table 5C, keeping them in mind the 30 amps that we had from table 2. And we got 9 conductors. So we're against 7 to 24 there. So that means that our correction factor is going to be 0.7. So we got 30 amps from table 2 times 0.7 from table 5C gives us a maximum of 21 amps that we can push through those conductors. Okay, let's go back to table 2 because that's most likely where we're going to end up. Next one, guys. Okay, so now we got ambient temperature above 30 degrees. So what I've got, this one is the ampacity for 10-2. Can I make that a little bit bigger? 2 seconds. Find the ampacity for a 10-2 armored cable, AC90, copper conductors. The size is obviously number 10s. We got RW90 XLP insulation, 600 volt rating, run in an area where the ambient temperature is going to be 45 degrees. Okay, so let's take a look here. How many we got? We only have 2 conductors, right? So we don't have to worry about 5C. So we're copper. We're in a conduit, so we're in table 2. We're in the 90 degree column here. So let's highlight that guy. And then size of conductor is number 10. So we're at 40 amps, right? So the maximum ampacity based off of table 2 is 40 amps. There's not more than 3 conductors, so we don't have to worry about table 5C, but the ambient temperature is above 30 degrees. We've said that it could get up to 45 degrees in that mechanical room. So we got to go to 5A. Okay, so first thing is we're looking at the 90 degree column, right? So we're looking at RW90 here. And the next thing we're going to do is we're going to go down to the 45 degree ambient temperature row. Okay, so we're right here, and we're going to find out where those 2 intersect. So it looks like 90 degree insulation temperature reading on our conductors, 45 degrees ambient temperature that it could actually get up to. So we have to derate the ampacity by 87%, right? So we're going to take the 40 amps that we found from table 2, multiply by 87%, and that gives us a maximum of 34.8 amps that we can push through those conductors. Okay, so hopefully you're cool so far on table 5A. Super simple. You're just looking at the insulation rating of your cables. Then you're looking at the max temperature that the ambient temperature can get up to, see where they intersect, and then use that multiplier and multiply your tables 1 through 4 ampacity value to find your maximum ampacity. All right, guys, let's do one more example. Okay, next one is find the ampacity for 3 copper conductors. Okay, so let's go back to table 2. Okay, let's get rid of this. Okay, so 3 copper conductors, so we don't have to worry about table 5C. What insulation rating? So we're at TW75, so we're 75 degree rating. Size of conductor is number 6. So that guy's good for 65 amps. Let's bring the answers up here. Okay, so it was in rigid conduit, went to table 2, found for number 6 in the 75-degree column is good for 65 amps. There's no more than 3 conductors run on the conduit, so you don't have to worry about table 5C, but we are above 30 degrees C. We're at 45. So let's go to table 5A. So keeping in mind the 65 amps that we had before, let's go to 5A. And again, we're at 45 degrees ambient temperature. The insulation rating is 75 degrees. And where those guys intersect, it looks like our correction factor is going to be 82%. So last step is we've got 65 amps times 82, or 0.82, sorry, to give us a maximum ampacity on those conductors of 53.3 amps. Okay, so hopefully everything worked out for you. Hopefully you were able to stop and start the video numerous times there as I went through the each of the examples. Let me know how this video is going. Tell me about the pace, whether I need to slow it down, whether I've explained everything in a proper fashion and not got drawn on about things. And if you want some additional questions, then I've got this chart right here. So let me bring this guy up. Make it a little bit bigger. So you can pause the video here. And instead of being those word examples, right now we've got the wire size, whether it's aluminum or copper, the insulation type and rating, whether it's conduit, free air, or cable, ambient air temperature, and then the maximum number of conductors that are in the cable or the conduit there. And then over here, you're going to find your maximum ampacity. So stop the video here, write these values down, and then see if you can find each of these guys. The answer's coming up in 3, 2, 1, and these are the values that I found. So let me know if I screwed up any of my examples going through, so we can put those in the comment section. But I went through them numerous times, so I'm fairly confident, 99.99% confident that I've gotten these guys correct. Okay, I've highlighted certain things like ambient air temperature being above 30 degrees here, right? So we're using table 5A to derate the values that we found in tables 1 through 4. Keep in mind whether it's copper or aluminum. I have one example here where it's aluminum conductor. And if it's more than 3 conductors, being this, and this example, we're going to have to make use of 5C in order to derate. All right, guys, hopefully you enjoyed this video. Hopefully I gave you enough examples. Let me know what you think. All right, we'll see you guys later. We'll see you in the next video.